Now see how to find definite integral on given interval for modulus function. You can see that here x minus 1 is given in modulus. In this question also terms are in modulus. So to integrate modulus function, we have to remove modulus sign. Without removing modulus, we cannot integrate, because in the list of formula we don't have formula to integrate modulus x. So first of all, procedure to remove this modulus. So see, in removing modulus we shall use a definition of modulus. If t is more than or equal to 0, then modulus t equal to t, and if t is less than 0, then modulus t is minus t. So this is property of modulus function. If a term inside modulus is positive, then when we remove modulus, term remains unchanged. But if value of term which is inside modulus is a negative, then removing modulus you have to keep here minus sign. So we should check sign of this function whether it is a positive or negative in this given interval. So here interval is 0, close interval 0 to 4. I am showing in diagram. Now inside modulus x minus 1 is given. So method is find the value of x for which this is 0. Find value of x for which this is 0. Whatever is term in modulus, its value is 0. So it is clear that if we take x equal to 1, for x equal to 1 this will be 0. So put 1 in this interval. See, 1 is somewhere here. 1 belongs to 0 to 4. So at x equal to 1 this is 0. And here in this interval, if x is in 0 to 1, so in this interval x has value less than or equal to 1. Here x is less than or equal to 1. If x is less than or equal to 1, that means x minus 1 is negative, less than or equal to 0. You can include here sign of equality for both statements. So when x is in this interval 0 to 1, that means x is less than or equal to 1. So x minus 1 is less than or equal to 0. And x minus 1 is less than or equal to 0. So t is less than or equal to 0. So modulus t equal to minus t. Now in this part, second part of interval, because of this 1, this interval is divided in two parts. Now here what happens, if x is here between 1 to 4, so if x lies in 1 to 4, so here x is more than or equal to 1. X is on right hand side of 1, so x is more than or equal to 1. We are using here 1 in both results. We are using 1 because at x equal to 1 term has value 0. So to check sign of this expression, we need sign of x minus 1, x plus x minus 1 in both the cases. Hence we are using 1. So x is more than or equal to 1, that means x minus 1 is more than or equal to 0. That is modulus x minus 1 equal to x minus 1. If t is more than or equal to 0, modulus t is t. So therefore integral is, this can be separated as 0 to 4. Now we express as 0 to 1 plus 1 to 4. So 0 to 4 equal to 0 to 1 modulus x minus 1 dx plus 1 to 4 modulus x minus 1 dx. In short, divide this interval 0 to 4 in parts. At which number we have to take parts? A number at which function inside modulus has value 0. So from 1 separate interval 0 to 1, 1 to 4. Now in 0 to 1, modulus x minus 1 is minus of x minus 1. So here I will keep minus of x minus 1 dx, and in this interval 1 to 4 modulus x minus 1 is x minus 1. So here it is x minus 1. So this is, it is 1 minus x. So it is 0 to 1, 1 minus x dx plus 0 to 4 x minus 1 dx. Now we can find its integral. Integral of 1 is x minus x square by 2. Here 0 to 1 plus integral of x is x square by 2. Sorry, here I have done mistake. Here it is 1. Lower limit is 1. 1 to 4. So x square by 2 minus x. Here 1 to 4. 0 to 1, 1 to 4. Now here 1 minus 1 by 2. Lower limit is 0. So minus second value will be 0. Plus, now calculating this expression, 4 square is 16. 16 by 2 is 8. So 8 minus 4. This is upper value. Minus value for lower limit. 1 by 2 minus 1. And now you can calculate this number, which is required integral. Second question. Here more than one terms are given. So first of all, separating this, I am separating 1 to 4 modulus x minus 1 dx plus 1 to 4 modulus x minus 2 dx plus 1 to 4 modulus x minus 3 dx. Now see, here 1 to 4. Now we want to remove this modulus. So as discussed in this question, we have to find the sign of this modulus. In this interval 1 to 4, if this is positive, if t is positive, modulus t is t. And if this is negative, modulus t will be minus t. So see, we discuss one by one. Here x is between 1 to 4. See, first interval is 1 to 4. X is between 1 to 4. Here x lies in 1 to 4. So obviously, if you observe this part, then you can see that x is more than or equal to 1. x is more than or equal to 1, therefore x minus 1 is more than or equal to 0. And if t is more than or equal to 0, modulus t is t. So therefore modulus t equal to t. So in this whole interval, when x is between 1 to 4, all x are more than or equal to 1. So all x belonging to this interval is satisfying this condition. So that is for this part. Now second part. Here x, what is value of x for which this is 0? Every time to remove modulus, the first step is find x for which term inside modulus has value 0. So if you observe this part, x minus 2, so putting it 2 here, this becomes 0. So we have to separate this interval from 2. So 1 to 2, 2 to 4, that we will do. Here if you keep x equal to 3, then this will be 0, and 3 belongs to this interval. So in third term we shall separate interval, or we will break interval at 3. So here I am putting this expression 1 to 4, say modulus x minus 1 is x minus 1. I am putting value of this first term. This is calculation for first term. It is x minus 1. First term is clear. No need to do here parts of first interval, because in whole interval this is positive. But here we have to do parts. At 2 we have to separate this. So 1 to 4 I am dividing as 1 to 2 plus 2 to 4. 1 to 4 is 1 to 2 plus 2 to 4. So at 2 this is separated. Here mod x minus 2 dx, mod x minus 2 dx. Now here 3 belongs to this interval. Between 1 and 4 there is 3. So separate at 3. So plus 1 to 3 plus 3 to 4. 1 to 3, 3 to 4. Mod x minus 3 dx. Mod x minus 3 dx. So this is first term, this is second term, this is third term. Now here we forward this as it is. At last we will keep all integrals. Now look here, x minus 2, we want to check value of x minus 2 whether it is positive or negative. So say x is less than 2. When x belongs to 1 to 2, that means x is less than 2. X less than 2, less than or equal to 2, so x minus 2 is less than or equal to 0. X minus 2 is less than or equal to 0, so mod x minus 2 is minus of x minus 2. So this will be equal to minus of x minus 2. Mod x minus 2 is minus of x minus 2. Now here always check relation of x with 2. Here to check sign of x minus 2 whether it is positive or negative, we have to check whether x is more than 2 or less than 2. And you can see that here x belongs to close interval 2 to 4. So x is more than or equal to 2. x is more than or equal to 2. So this is more than or equal to 0. So modulus t is t. So 2 to 4 x minus 2 dx plus. Now here, when this is 0, at 3 it is 0. So that's why we separated at 3. Now in this interval, we want to check sign of x minus 3. So here values of x are less than 3. X belongs to close interval 1 to 3. So x is less than 3. The mod x minus 3 is negative. So mod x minus 3 is minus x minus 3. Limits 1 to 3 dx. Here x is more than 3. So this is positive. So plus 3 to 4 x minus 3 dx. So modulus is removed. Now here integral of x is x square by 2 minus x 1 to 4 minus, here integral is x square by 2 minus 2x plus x square by 2 minus 2x 2 to 4 minus x square by 2 minus 3x plus x square by 2 minus 3x. So putting all integrals, and now upper limit minus lower limit. Putting this 4 here, 4 square 16 by 2 is 8. 8 minus 4 minus, now I am putting 1 by 2 minus 1. So this is value of first term minus, now I am putting value of second term. Putting here 2 square is 4 by 2 is 2 minus 2 into 2 4. So upper limit is taken, now minus lower limit. So 1 by 2 minus 2 into 1 is 2. So this is second term plus, now upper value 4 square is 16 by 2, 8 minus 4 into 2 8, 16 by 2 8 minus 8. Upper value taken minus lower value, 2 square 4 by 2 is 2 minus 2 into 2 4. This is done. Now minus, putting here 3 square is 9 by 2 minus 3 into 3 9. Upper limit taken minus lower limit 1 by 2, putting 1 here, 1 by 2 minus 3, then plus putting here 4 square 16 by 2 is 8 minus 12 minus 3 square is 9 by 2 minus 9. So simplifying this, it is equal to 8 minus 4 is 4. This is minus half, minus plus half, minus 2 minus 4 is minus 2. This is minus 3 by 2. So minus plus 3 by 2 plus, this is 0, minus of minus 2, that is plus 2, then minus, this will be minus 9 by 2 minus 3 to 6, 1 minus 6 minus 5 by 2 minus minus plus 5 by 2. Then last plus 8 minus 12 is minus 4 minus minus 9 by 2. So minus minus plus 9 by 2. So now opening these brackets, 4 plus 1 by 2, 9 by 2. Here minus 4 plus 3 minus 1 by 2. So minus minus plus 1 by 2 plus 2. This is minus 4 by 2. So minus 2 minus minus plus 2. This will be minus 8 plus 9, 1 by 2. So it is equal to 9 plus 1, 10 plus 1, 11 by 2 plus 4. 4 into 2, 8. 11 plus 8, 19 by 2. So value is 19 by 2. To integrate sin x into cos x upon cos raised to 4x plus sin raised to 4x over 0 to pi by 4. So here method is we divide numerator and denominator by cos raised to 4x. Dividing numerator and denominator by cos raised to 4x. Say here cos raised to 4x plus sin raised to 4x sin x into cos x. This is given. Whatever is given I have written as it is. Now what we do? I divide by cos raised to 4x. Cos raised to 4x. And here I divide by cos raised to 4x like this. Cos x into 1 by cos square x. Divided by cos raised to 4x, cos raised to 4x. So from numerator, this is cancelled. This becomes sec square x dx. 0 to pi by 4. 10x, this is 10x. 10x into sec square x dx. Denominator is, this is 1 plus, this will be 10 raised to 4x. And now say, it is becoming integrable form. If you observe this part in numerator, if we want to remove this 10x sec square x with dx, then we have to take substitute 10 square x equal to t. So here if we take 10 square x equal to t, so here this will be 1 plus t square, because in any formula we don't have raised to 4. There is no any formula for integral of something upon 1 plus t raised to 4. We are having for t square. So taking 10 square equal to t, here we will convert this into square. So 10 square x is t. Now differentiating this, derivative of 10 square x is 2 10x into derivative of 10x is sec square x. Dx is dt. So 10x into sec square x dx is dt upon 2. So this will be dt upon 2. And when we change a variable, limit should be changed. Now changing limit, and when x is 0, put here 0, t is 0. And when x is pi by 4, put here pi by 4. So t is 10 square pi by 4 and 10 pi by 4 is 1. So integral is, therefore integral is 0 to 0 will be replaced by 0, pi by 4 will be replaced by 1. This will be dt upon 2, and here 1 plus 10 raised to 4, that is t square. Now its integral is tan inverse t 0 to 1, that is 1 by 2 times tan inverse 1 minus tan inverse 0. So this is pi by 4 minus 0, so value is pi by 8. So remember, in the beginning here, divide numerator, this is the key point, divide numerator and denominator by cos raised to 4x. This is the key point for first beginning. Now in this question, say with dx sin x plus cos x is given. So whenever with dx, if you are given sin x plus cos x or sin x minus cos x, always apply this trick, that sin x plus cos x, think about what is the antiderivative of sin x plus cos x. Check antiderivative of sin x plus cos x. So see, antiderivative of sin x plus cos x, that means integral. Integral of sin x is minus cos x. Integral of sin x is minus cos x. Integral of cos x is sin x. Positive I am putting first, negative second. So antiderivative of sin x plus cos x is minus cos x plus sin x. That means if we take this part equal to t, then its derivative will be cos x plus sin x dx equal to dt. So this will be removed. So here we are taking substitute by logic, that think about antiderivative of this part. Its antiderivative is sin x minus cos x. So we are taking sin x minus cos x equal to t. Sin x minus cos x is t, therefore cos x plus sin x, derivative of sin x is cos x and its derivative is plus sin x, dx is dt. So when we apply this method, when here sin x plus cos x given or sin x minus cos x given or cos x minus sin x given, then we apply that method. Suppose in this question, suppose that in that question, in numerator, suppose you are given cos x minus sin x dx. Suppose this is given in this question. Little change. Then what we should do? So think about antiderivative of this function. Cos x, its antiderivative is sin x minus keep as it is. Antiderivative of sin x is minus cos x. So minus plus cos x. So take its antiderivative equal to t. So then in the next step, taking this as substitute, now its derivative will be cos x minus sin x dx equal to dt. So this can be removed. So remember, whenever numerator is sin x plus cos x or cos x minus sin x or sin x minus cos x, always apply this method to decide to take a substitute. In most of the question, whenever we take substitute, So that part is always visible in question, either in denominator or numerator. But here we are taking substitute for sin x minus cos x, but sin x minus cos x is not visible in denominator or in numerator. So we will make it visible, even though here this should be converted in terms of t. Whenever we take substitute, everything should be converted in terms of new variable t. So this is replacement for numerator. Numerator is dt. So we will keep here dt. Now what about sin 2x? It should be also converted in t. So value of sin 2x, it can be obtained from this substitute. So see, for that what we do? Squaring this on both sides, and now taking here square, sin x minus cos x whole square equal to t square. Square is taken, therefore expanding this, sin square plus cos square, that is sin square x plus cos square x minus 2 sin x cos x equal to t square. Now this is 1, so 1 minus, and this is sin 2x. You can see that we are going to get value of sin 2x. So sin 2x is 1 minus t square. So here this is value of a term which is in denominator. Value of a numerator is already here. Now we have to change a limit, and when x is pi by 6, put here pi by 6. So t will be equal to sin pi by 6 is 1 by 2, cos pi by 6 is root 3 by 2. When x is pi by 3, when x is pi by 3, sin pi by 3 is t equal to sin pi by 3 root 3 by 2, cos pi by 3 1 by 2. You can see that both are opposite numbers. So putting these all values in this question, so integral is, therefore integral is pi by 6, it will be replaced by 1 by 2 minus root 3 by 2. Pi by 3, it will be replaced by root 3 by 2 minus 1 by 2. Numerator is a dt upon sin 2x is 1 minus t square. And we know that its integral is sin inverse t. Lower limit is 1 by 2 minus root 3 by 2. Upper limit is root 3 by 2 minus 1 by 2. So putting value, sin inverse root 3 by 2 minus 1 by 2 minus sin inverse 1 by 2 minus root 3 by 2. Now here, using a property of inverse trigonometric function, when sin inverse is working on any number, if we change inner sign, then outer sign will be changed, plus sin inverse root 3 by 2 minus 1 by 2. So this is 2 times sin inverse root 3 by 2 minus 1 by 2. So this is required integral. Now to integrate this function, say here a cos square is given, here cos square, here sin square. Say 0 to pi by 2, cos square x we keep as it is, cos square x plus 4 into, now this number I am converting in cos square. So it is 1 minus cos square x. This is beginning. Convert this sine square into cos square. So it is equal to 0 to pi by 2 cos square x dx upon cos square x plus 4 into 1 is 4 minus 4 cos square x. So 1 cos square x minus 4 cos square x minus 3 cos square x. So completely in terms of cos square x. Now see what we do. 0 to pi by 2. This is 4 minus 3 cos square x. Here I am putting cos square x. I have kept as it is. Whatever is given as it is. Now what we do? This is minus 3. So I multiply by minus 3, divide by minus 3. That means value remains unchanged. Now here is 4. So add plus 4 and subtract same number. Adding and subtracting 4 in numerator. So this can be expressed in this form. Without changing value, we can do like this. So minus 1 by 3, 0 to pi by 2. Now here we can see that this is same. So dividing this number, this is 1. So 1 dx, or simply we can keep dx, minus 4 into minus 1 by 3. So minus minus plus 4 by 3 dx upon 4 minus 3 cos square x. Now to integrate this, I am dividing by cos square x. Minus 1 by 3, this is integrable. Integral of 1 is x. We can keep value. Plus 4 by 3 dividing by cos square x. So sec square x upon 4 by cos square, that is 4 sec square x minus 3. Here divided numerator and denominator by cos square x. Numerator and denominator by cos square x. So it is equal to minus 1 by 3 upper value minus lower value pi by 2 minus 0 plus 4 by 3. Now here lower limit is 0, pi by 2, 0 pi by 2. So 4 by 3 times 0 to pi by 2 sec square x dx upon, now we keep here 1 plus tan square x, 4 into 1 plus tan square x minus 3. Convert sec square into tan square, 1 plus tan square. So this is minus pi by 6 plus 4 by 3, 0 to pi by 2 sec square x dx upon 4 tan square x plus 1, 4 tan square x plus 1. Now we take, to remove this sec square x dx, we have to take tan x equal to t. So what we do here, we take 2 tan x equal to t. 2 tan x is t. So here this will be t square. 2 tan x is t. So 2 into sec square x dx is dt. So sec square x dx is dt by 2, and changing value when t is 0, this is x is 0, put here 0, t will be 0. When x equal to pi by 2, putting here pi by 2, tan pi by 2 is infinity. 2 into infinity is infinity. So therefore integral is minus pi by 6 plus 4 by 3, 0 will be replaced by 0, pi by 2 will be replaced, pi by 2 will be replaced by infinity. Sec square x dx is dt by 2. This by 2 we include here, so this will be by 6 upon 2 tan x is t, so it will be t square plus 1. So it is equal to minus pi by 6 plus 2 by 3. Its integral is tan inverse t, 0 to infinity. So minus pi by 6 plus 2 by 3 into, this is tan inverse infinity minus tan inverse 0. So minus pi by 6 plus 2 by 3 into tan inverse infinity is pi by 2 minus 0. So this is minus pi by 6 plus pi by 3. So final value is pi by 6. Integral of log cos x over interval 0 to pi by 2. Let me take this as I. I is 0 to pi by 2 log cos x dx. Say in the beginning we use rule over 0 to a integral of fx is, we replace x by a minus x. So here because lower limit is 0, upper limit pi by 2, I replace here x by pi by 2 minus x. So 0 to pi by 2, this is I, log of cos of pi by 2 minus x. So this becomes sin x. So I is 0 to pi by 2 log of sin x dx. Now here we are adding this equation 1 and equation 2. Adding 1 and 2, if here in question instead of cos x, if you are given sin x, then you will start from sin x, sin, then this will be cos. So we will have log of cos x. So if sin x cos x is given, you will have here sin x. If sin x is given, you will have log cos x. So there are such two questions, log cos x. Similarly you can be given log sin x. So at equation 2, when you add 1 and 2, you will have similar expression in both questions. So adding 1 and 2, I plus I is 2i, 2i is 0 to pi by 2 log cos x plus log of sin x dx. This is equal to 0 to pi by 2. Now log a plus log b is log of ab. Log a plus log b is log ab. Now this is sin 2x divided by 2. So here 0 to pi by 2, 2y is 0 to pi by 2 log of sin 2x divided by 2 dx. Now here applying working rule of log, 0 to pi by 2 log of sin 2x minus log of 2 dx. Now separating this part, 0 to pi by 2 log of sin 2x dx minus, this is constant, so log 2 take outside, 0 to pi by 2 1 dx. Now say we say this is I1, इसको we call this first term as I1, so it is equal to I1 minus log 2 into integral of 1 is x, 0 to pi by 2. Let me say this is equation 3, where I1 is 0 to pi by 2 log of sin 2x dx. Now to integrate this function, see what we do, the procedure is we take 2x equal to t. Here we have log sin x, it is I. So if we take here t, then we can have log sin t, similar like this. So we take substitute 2x equal to t. 2x is t, so 2 dx is dt. So dx is dt by 2. And when we take substitute, way to change limit. So when x is 0, putting x 0, t is 0. And when x is pi by 2, put pi by 2, t is pi. So converting this in t, I1 is, so I1 is equal to 0 will be replaced by 0, pi by 2 will be replaced by pi, log of sin 2x is t, dx is dt, and by 2 keep outside. Now see, here we are getting this type of expression, ditto expression log sin t dt, but this number is different. Here upper limit is now pi, but if we can convert that pi into pi by 2, then that term can be replaced by I, so this value can be used. So to convert this pi into pi by 2, see we are going to use one rule. Previously we discussed the rule that if f of 2a minus x is equal to fx, then 0 to 2a fx dx is equal to 2 times 0 to a fx dx. When discussing properties of a definite integral, we use this rule that if f of 2a minus x is fx, then 0 to 2a fx dx is 2 times 0 to a, means whatever is this number, it is converted into half. Here we have pi, here we have pi, and we want its half, pi by 2. But it can be done if it satisfies this property. So consider this number as a 2a, and we check is this condition satisfied in this question. So if we say this is f of t, let f of t is log of a sine t. Suppose this is f of t. Now we check this property, f of 2a minus t. So what is 2a here? 2a is pi. So f of 2a minus t equal to log of sine of a pi minus t. It is equal to log of sine t, and this is equal to f of t. We are getting same. So f of pi minus t is ft. F of 2a minus t is ft. This condition is satisfied here. Therefore, here this will be converted into half by multiplying by 2. Therefore, I1 is 1 by 2. Now using this rule, this was 0 to 2a, 0 to 2a. Now what I do? 2 times 0 to a. So 2 times 0 to half. Fx dx, ft dt. This 2 it will be cancelled. So it is 0 to pi by 2. In definite integral, instead of t, if I keep x, it remains same. So only changing symbol in definite integral, value remains changed. So t can be replaced by x. These are same. Now see, what is it? It is I. From 2 we are getting value. So it is I. This is from 2. So putting this value in 3. So from 3, I is equal to I1. I1 is how much? I1 is I. So I keep here I. 2I is I1. I1 now we have obtained I. So I minus log 2 into pi by 2 minus 0. So therefore 2I minus I equal to minus pi by 2 log 2. Therefore integral is minus pi by 2 log 2. This is required integral. So in this question, this rule is used. This is used in this question. Say this question is from indefinite integration. Indefinite integral of this function. This is a very good question given in textbook, showing by easiest method. So here this is composite function of log x. You can see log of log x, 1 upon log x square. So the easiest way is take log x, substitute, take log x equal to t. And whenever we take log x equal to t, x is e raised to t, because here base of log is e. So dx is equal to e raised to t dt. So integral is, putting values here, log of t plus 1 upon t square, and dx is e raised to t dt. Now see, whenever we have e raised to x and besides e raised to x there is a function of x, then always we try to apply this rule. When here e raised to x, fx plus f dash x, always we try to apply this rule. In any question of integration, whenever you have e raised to x and a combination of x, function of x. So besides e raised to x, there is a function of x. Then whatever is besides, you can separate them in two parts. Try to get two parts in which one part is f, other part is f dash. So say here, this is, now here we are trying to set fx means function of t, and here f of t, e raised to t dt. So here log t, I am putting log t. If log t is in first part, its derivative should be in second part. Here we are setting f dash. Log t is a part of f, so derivative of log t is 1 upon t. Derivative of log t 1 upon t. Now this is extra, it's not given in question. Nowhere here 1 upon t is given, but we cannot add anything extra. So what we do, whatever is added, I subtract here. Means nothing has been done. But because this number is extra, its derivative should be here. Now what is derivative of minus 1 by t? Derivative of minus 1 by t is plus 1 by t square, and which is already given. So this function is divided in two parts. This part is f, this part is f dash. So fx plus ft plus f dash t into e raised to t is equal to ft into e raised to t plus c. And putting a value of t, it is equal to log of t is log x minus 1 upon log x into e raised to t is x plus c. This is required integral. Now see here a pattern is, if this type of integrand is given, first is linear part px plus q, first bracket contains linear polynomial, and in the square root radical sign ax square plus bx plus c is given. To integrate such functions, here any polynomial, a linear polynomial can be given. This can be expressed as m into d by dx of ax square plus bx plus c plus n. This is the beginning. Remember this method. Only you remember beginning. See what is the starting. See here we take x plus 3 linear part. This is linear part. It can be expressed as m into d by dx of 3 minus 4x minus x square. This is quadratic part plus n. Now from this calculation m and n can be found. So m into its derivative is minus 4 minus 2x plus n. This can be expressed as minus 2m into x plus n minus 4m. Constant part separated, x part separated. Now compare both the sides. Here coefficient of x is 1. This is 1. So minus 2m is 1. Minus 2m is 1 and n minus 4m is 3. Constant equal to constant. Coefficient of x equal to coefficient of x. So m is equal to minus 1 by 2. Putting here minus 1 by 2, minus 1 by 2 minus 4m is 3. Therefore 4m is minus 1 by 2 minus 3. So 4m is minus 7 by 2. So m is minus 7 by 8. So here, sorry, I have done mistake. Here there is a mistake. Value n minus 4 into, what is m? Minus 1 by 2. M is minus 1 by 2 equal to 3. So n plus 2 equal to 3. So n is 1. So m is minus half, n is 1. So here we shall use this replacement for x plus 3. So this will be replaced by this new expression with value of m and n. Therefore from 1, x plus 3 can be expressed as m minus 1 by 2 into minus 4 minus 2x plus n plus 1. So using this in required integral, therefore integral is, now putting replacement for x plus 3. X plus 3 is minus 1 by 2 minus 4 minus 2x plus 1. This is value of x plus 3 into square root of 3 minus 4x minus x square. Then in the next step, multiply individually. We multiply this number with this and multiply this one with this number. So it is equal to minus 1 by 2. Multiplying these two numbers, I am putting this number first. Square root of 3 minus 4x minus x square into this on right side. Minus 4 minus 2x. This is taken out and dx. Plus here 1 into this number. So square root of 3 minus 4x minus x square dx. Previously we did a method in which quadratic polynomial with radical sign, it was in denominator and a linear part was in numerator. We did this method previously. To integrate such function, whatever was the beginning, same beginning is here. In this method, after getting new expression for px plus q, putting new expression for px plus q, we divided individually. Here multiplied individually. So mechanism is same. Then now here this we say I1, it is minus 1 by 2 times I1 plus I2. This is I2. Now we find I1 and I2. So here I1 is square root of 3 minus 4x minus x square minus 4 minus 2x dx. This is I1. We suppose that this is equal to t. Let 3 minus 4x minus x square is t. Therefore minus 4 minus 2x dx, it is dt. So I1 is, this is t, so root t, so t raised to half into this becomes dt. So it is equal to t raised to 3 by 2 upon 3 by 2 plus c. That is, it is equal to 2 by 3 into value of a t is 3 minus 4x minus x square raised to 3 by 2. Here we say c1. So this is I1. And I2 is I2 and I2 is, this was I2, square root of 3 minus 4x minus x square. Here we convert this in perfect square polynomial. X square term is negative, so set perfect square in second place, remaining number in first place. This is minus x square, so keep minus x square minus 4x. Now splitting of 3. Because this is negative, here last number should be negative. And here last number, to make this perfect square, it must be 4. So we have taken here minus 4, but we are having 3. So we should keep here 7. 7 minus 4 is 3. So this is then square root of root 7 square minus, this is x plus 2 whole square. Now x plus 2 is t. Take x plus 2 is t, so dx is dt. So I2 is square root of root 7 square minus x plus 2 square, this is t square dt. And integrating this formula for root a square minus x square, so x by 2 root a square minus x square plus a square by 2 sine inverse x upon a plus we say c2. X by 2 root a square minus x square plus a square by 2 sine inverse x upon a plus c. We worked on this formula. So it is equal to t is x plus 2 by 2 square root of 7 minus x plus 2 plus 7 by 2 sine inverse x plus 2 by root 7 plus c2. Now this is equal to x plus 2 by 2 square root of, now say it's a simple form. Its simple form is 3 minus 4x minus x square. 3 minus 4x minus x square plus 7 by 2 sine inverse x plus 2 by root 7 plus c2. So this is I2. Here it is I1. I1 and I2 both are obtained, and these values now we are going to put in equation 1. So putting in equation 1, value of I is equal to minus 1 by 2 times I1. What is I1? 2 by 3. It is 2 by 3. 3 minus 4x minus x square raised to 3 by 2 plus c1. So minus 1 by 2 times I1 plus I2 plus, this is I2, plus x plus 2 by 2 square root of x square 3 minus 4x minus x square plus 7 by 2 sine inverse x plus 2 by root 7 plus c2. So it is equal to, multiplying this number, minus 1 by 3, 3 minus 4x minus x square raised to 3 by 2 minus 1 by 2 into C1, that we will join in C, plus x plus 2 by 2 square root of 3 minus 4x minus x square plus 7 by 2 sine inverse x plus 2 by root 7 plus C, where C is equal to minus 1 by 2 C1 plus C2. So this is required integral.